Welcome to the Startup Grind.
I'm going to let Chance start the interview. You guys take it away.
Okay, thank you, Eddie. And thank you, Zach, for coming to Guangzhou and meeting the Startup Grind Guangzhou community.
Yeah, it's my pleasure.
As usual, we started with a personal introduction. Can you tell us a little bit more about yourself?
Oh yeah, sure. So let's see. I am a hacker, maker. I love the internet and robots, and been in China for about 2 years. Oh, I have proof that I love the internet too. This is my only tattoo. It's an Ethernet port. The internet flows through me, and I'm also really addicted to it. But yeah, so I've been living in Shenzhen for about 2 years now, and I just really like China. Like, it's a really unique place, and just the best place I found in the world to make and build things. And yeah, so just been exploring and learning and living.
Yeah, I had a general question to ask you about the now affordable 3D printing technologies. About 10 years ago, I heard about a technology called rapid prototyping in the manufacturing sector in China. Back then, a system like that cost millions of yuan, RMB. Can you share with us, from a historical perspective, of what are the major differences and similarities between the rapid prototyping technology back then and the 3D printing technology that you're building right now?
Yeah, so I guess the big difference is kind of the mindset of how people approach the technology. Like 3D printing as an industry has been around for at least 40 years. Like I believe it started in the 60s with like stereolithography, which is using light to cure some sort of resin and build a three-dimensional shape out of it. And so this all came about in like the 60s and 70s. You had like 3D Systems and Stratasys and these companies building these big commercial size, like I call them mainframe 3D printers. And I think that 3D printing has paralleled computing in a lot of ways. And you know, so these guys kind of paved the way. They built these big machines. They built them to like extremely high precision because the people that wanted them were the people doing prototypes to prepare for mass production. And you know, the big thing that has really allowed 3D printing as like a consumer level technology to kind of blossom and come forward is that it's just the patents expired. And so, you know, these companies who created this technology like only had one kind of vision of what it should be. Like, let's build really precise and expensive machines to do this one kind of technique. But you can also build less expensive, less precise, more accessible machines that do basically the same thing and make it accessible to more people. And you know, a lot of the people that buy 3D printers, they're not prototyping in the same way that like a design engineer at a big factory or at a design firm will prototype. You know, these are guys that have a dishwasher and, you know, take the calipers to the knob that broke and said, okay, that's 6mm shaft with 5mm flat, make some like clunky knob and be like, hey, look, honey, I fixed a dishwasher. And then, you know, and it's just the kind of thing they have around in their house as like a toy or for fun. And, you know, some people are making art with them. And it's just a different way of looking at it. And, you know, a different way of being able to use it as well. Because, you know, when you went from the mainframe to the personal computer, like when you had a mainframe computer and it was expensive and the time on it was expensive and it was limited access, you know, you couldn't do things like make games for it because that's such a frivolous use of this expensive technology. But with 3D printers that are like low cost, that the materials are low cost and the you know, the actual cost to own one is low, you know, you can make weird, goofy things. Like, you know, one of the things that was really popular in Thingiverse for a while. So Thingiverse is a site that we created with MakerBot. It's kind of like a YouTube for stuff, where like people upload their 3D models, anybody can download it and print it on their 3D printer. And so, you know, there's been a few waves of like memes on there, but you know, one of them was like heart gears. And so some like clever mechanical engineer figured out a way to make these gears that like like I think the first one was a cube, and there's gears internally, but outside it's a cube. And if you rotate the edges, it like kind of explodes out, and then it goes back into a cube shape. And then someone like generalized that, and all of a sudden you have like hearts and just weird, like just all sorts of different shapes that are all kind of like here, and then it rotates out, and then it comes back in. And you know, you have all these people experimenting and building and doing things that, you know, if on something that's expensive, you really have to kind of like plan and say, and you have to justify, like, why are you going to build this thing? Because it's going to cost us this much money. But if the cost to use something is so much lower, you can just try it. You know, you kind of like, you can just throw stuff at the wall and see what sticks and what doesn't stick. And, you know, I think it's just a way of thinking about the machines. And I also think that, you know, the patent system is completely, totally broken, because, you know, these guys, like, here's this big grand idea, like, let's make 3D objects with a machine. But their idea was just one tiny corner of that, of like, let's make really high precision, expensive objects with this technology. Whereas, you know, there's all sorts of different ways to achieve that goal that could have been really cool 20 years ago. I mean, and there's no reason, like, none of this technology is really rocket science. It's just, these guys thought of it first for this one application, but really there were all these other applications. And you know, so
talking about applications, because I tend to think that probably printing, the board printing is not as precise as replicating, because as I read from the internet about your vision for the future, particularly for building things like a machine that can build itself.
Oh, yeah.
You know, the idea that, you know, it also scares me at the same time, because it reminds me of stories from a famous movie called Artificial Intelligence, where human has no role in the future, only the machines are taking over. What is your take on that future about humankind?
Well, I mean, having built these machines, like, you don't have anything to worry about just yet. But
He's a robot.
But I do think that as digital fabrication technology gets more accessible, it's just going to allow more and more people to design things and share them. You know, one of the things that has been kind of a trend in the past, I don't know, 5 or 6 years is open source hardware. And I believe that a lot of this has been driven because so much of the design nowadays is done digitally in CAD, and you know, you basically do all of your work digitally, and then at the end you run it through some sort of process and you get your thing. Whereas like before, and I guess with that is hobbyists are starting to understand how to do that process. I mean, I remember like 7 years ago or so, like learning how to use a laser cutter for the first time and being like, oh my God, this robot is cutting stuff with lasers. But you know, like nowadays, like most people understand like what a laser cutter is and how it works. And so, and because, you know, most people like our age and older and younger, they grew up with the internet. They grew up with this idea that like information, the cost to copy information is zero. Like on the internet, sending something from me to you, like it doesn't cost anything. Like it's basically free. And so if we share all the time with like photos, movies, ideas, just the whole thing. And so the idea with things now is that it's just digital, it's just a file, and if you have the right machine on the other end, you can send a thing through the internet to someone else. And I think because of that, you're seeing a lot of open hardware, because people understand that, you know, it's just digital information now. And it also allows people to collaborate a lot easier because you can shoot files around.
Okay, interesting. And coming back more to more practical purpose of 3D printing, if I'm building a new product, hardware product, what are the immediate engineering and financial benefits of using the kind of 3D printing technology that you're building? Yeah,
definitely. So, I mean, I think, so you mean like having a 3D printer on your desk next to you. Like the biggest one, I think, is just having rapid iteration cycles. So in hardware, one of the big challenges, if you don't have a 3D printer, like let's just say mechanical engineering, you make a design, you get it to the point where you think, okay, that's good, and then you send it off to someone to get made, and then anywhere from like a day to 3 days later, you get the next version. And you say, oh, well, that's wrong, and this doesn't feel right. And so you make another change, and you send it off 3 days later, and you get it back. Now compare this to like web development or software development, where you make a prototype, you make something, you test it, and then you start like, and it's immediate. You compile it, you upload it to the web, you do whatever it is to test it, and there's this immediate feedback loop where you can see what's wrong or see how that affected your design, and then make a change. And iterate really quickly. I mean, this is why the web and internet has all of these things like agile development and like lean blah, blah, blah. It's because you can, because the cycle times are so low. And in hardware, getting that shorter makes things faster. So, you know, if you have a 3D printer on your desk, you say, here's my design, click a button, and an hour or 2 hours later, you have the next version. You can iterate on a design, the same design, like 4 or 5 times in a day, depending on how
4 or
big
5 times a day.
I mean, if you have something that's small that only takes you know an hour to do, you make a design, you change a few things, do another one, and you can really quickly crank through some prototypes.
How about for things like the size of a car, and what are the time for given existing 3D printing?
So I went to a prototyping shop in Shenzhen that does like car parts, and I mean basically those guys all do it as CNC, which is another digital fabrication technology. And,
in terms of technology and the sharing of technology, I had a really curious question. Why do you believe that making the 3D printing technology should be should be open and just like everybody can have free access to that kind of knowledge? And I think this is a this open or not open has been a major debate all around the world.
Yeah, so I mean, I guess there's a couple of reasons. One, I'm sort of a hippie, so like not in the like traditional like trees sort of sense, but in like I don't know. I just like I feel like I should just share this stuff with the world because I think it'll make it a better place. But also because when I got started in technology like long time ago, I got started in web development, and one of the big reasons I believe that the web has been so successful is that it's been built on open technologies. Like when I was 14, I did not have money to spend on like a web server, and like I couldn't buy software to like tinker and just build a stupid little website. But like because HTML was open, because the tool like you needed a notepad, and there's like free web, there's Linux and all that stuff. Like I was able to just jump in there, play around with it, learn from it, build it, and go on to do professional things. And then as I got more into it, and as the web matured, there's all of these technologies like PHP, Ruby, MySQL, and all of this stuff, and it's all free, and it's sharing and collaborative. And I think the web has become a better place for that. Like there's certainly so many technologies
because of open source.
Yeah,
free
because
sharing.
Yep.
The software technologies.
And I think the ideas are a lot better as well when you have this kind of sharing of people like, hey, I made this, and then someone says, oh, well, this is cool, but we made an even better one, and it kind of goes back and forth. And when it's not a big deal that, hey, you took these ideas from here, but then like made them even better. I just think it's good. It's a healthy culture when you can do that sort of stuff.
Yeah, but from a business point of view, it's particularly for people directly involved in the business of making 3D printers, how would they make money from the model? I mean, in software, an open source software world, we already had model evolved like the Red Hat model, but in hardware world, particularly in terms of 3D printing technology itself, how will people make money from or around these technologies? What are the business models that you can envision that are going to
I mean, in hardware, it's actually really easy. It's really straightforward because you're selling a physical good. And you've heard the mantra 100 times that hardware is hard because it is difficult to get everything right. Like even with a 3D printer, there's variations in from each part it produces, and you know, like MakerBot, we're a great example. And unfortunately, it's not open source anymore. It's one of the reasons I'm no longer there. But you know, we put our design out there. People were copying it, but you know, we bought some of those machines, and our machines were better because we designed it. We knew why the design was that way. We knew all the nuances of putting these things together, and you know, I think people understand that on some level, that if you buy it from the people who actually designed it, you're going to get one that's put together as it was intended. Whereas if you buy one from like a knockoff, I really don't like the word knockoff because it was open so other people could make it. Like
Shanzai.
Yeah, I mean Shanzai is probably a better word. But you know, these people were doing what we intended, like making their own. I mean, you hope that they'll modify it themselves. But you know, I think getting back to the original question, like people want to go to the creators because they know they'll get the high quality. I mean, if you care about quality, you're willing to pay the extra amount to get the good one. I mean, that's why people buy Apple products. Like you can get copies of it, but they're not the same. I mean, there's even people that go through, tear down every single component and you know, copy things. But you want to get it from the source because that's the best. Or if price is what you care about, you know, who cares? Like, just go get the cheap one.
Okay.
Like, and I do both. You know, like all like for things that you know, I just want something cheap. Like I'll just go buy like the generic brand, and if I want something like really nice, go buy the name brand. And
Since you already left your previous staff, why you choose Shenzhen or China as your new place of work?
I mean, I came out here for MakerBot to set up China manufacturing and operations. And when I left last year, I basically like moved my whole life out here. And you know, while I was out here, I really fell in love with this place and just enjoyed kind of the lifestyle and being out here. And you know, for someone who's never been to China before, and, like, this is an adventure. Like, it's totally new, and every day is exciting. And you know, I also believe that, like, as a human being, you should be learning and experiencing new things all the time. And somewhere like China, it's so easy. You're basically forced to learn and experience new things every day. So.
But since you grew up in the U.S. and you work for some time in the U.S., but what are the things that you miss most in the United States that you can't easily find here in China?
Internet. I miss internet.
Okay, also you say free internet. Yeah, if I had the power to make Shenzhen and China the better place for you to realize your next maker dream, what would you? What are your top 3 wishes?
Like wishes? Oh man!
I mean,
can you make me good at Mandarin?
Awesome. Yeah, that would be one.
Yeah, that's really. Everything else is great. I mean, Shenzhen is awesome. You know, all of the resources there to design, prototype, and build are. They're so easy to access.
You mean in Huaqiang Bay?
And
all
Huaqiang
the ecosystem
Bay,
around it.
Yeah, there's so many. Like Huaqiang Bay is great because all of the things are there for like prototype and small volume of electronics, but also on the mechanical side, like there's laser cutters on the street. There's you know, all sorts of prototyping factories that have really nice high-end tools. There's manufacturers that are willing to like give you a tour and answer questions. I mean, I've learned so much just like going on like factory tours to like find like, oh, you know, I don't know anything about vacuum molding. So like find a vacuum molding place on there and be like, what's that? What's that? Well, you know, I feel like I'm like 7 years old again. And like, why? You know, like little kids, that's like their favorite word, is like why. And you know, it's like it's the kind of place where, you know, you can read about something, and you know, I've read on the internet, like vacuum molding is a good one because I don't have a ton of experience with it, but read on the internet, okay, it's like it's a really low cost and the tools are really cheap, and you know, but it's not as accurate and stuff. And you go in there and you look at all the stuff and you're like, how'd you do this and how'd you do that? And like you get real concrete answers, like how much was this and how much was that tool? And you know, the people will just be like, oh, okay, well that was like 600 kwai and that was like 5 kwai per piece. And you really get the kind of information that is just not on the internet.
Do you think those kind of supplier and makers information that important for a company who want to build their own hardware products and make it big? How important is that feedback from their suppliers?
Yeah, I mean, I think it's critical. I mean, I think so many people, like designers in particular, are kind of guilty of this designing in a cave where they're just like have this beautiful like perfect CAD model, but like as soon as it hits reality, like there's no thought of like how are we going to make this. It's just like we'll give it to the factory and they'll magically produce this. Whereas like I don't know, I'm kind of more of a practical engineering kind of guy, and like I want to start from the beginning and be like, okay, I want to use these kinds of techniques, or like I have this target for how much this thing should cost, and like what's available to me, like you know, what are my volumes, and look at that from that side of things. It's like, okay, well I could use like laser cut stuff because there's no tooling, or I could use, you know, maybe vacuum forming, or you know, like maybe if I get to a big enough scale I could use injection molding. And you know, I want to be able to talk to the people and find out like what are the prices, and because there's like designing something in hardware, there's 100 different ways to do it, and if you go down one road you could end up making something that's manufacturable but really expensive. So you got to kind of like make all the right decisions. And you know, if you're just, you know, I think that price is such an important part of the design equation, and I see a lot of people that just wait until the very end of their design project to be like, all right, now let's make the bill of materials and fill in the prices, and they're like, oh my God, why is it like 4 times what I thought it was going to be? Whereas like I like to kind of price it out from the beginning and see like,
from the very beginning.
Am I in the, you know, maybe not final price, but am I in the right ballpark? Am I in the right order of magnitude of price here? Okay. And getting like early quotes from manufacturers is a big part of that.
Yeah. Since since you're involved in a accelerator, an incubator kind of thing for hardware, so what is the role of a VC for the hardware stuff, and how is accelerator is going to be different from other VCs or incubators?
Yeah, I mean we're like definitely could consider us like venture capitalists, but we're like, I don't know, not your typical ones, because we just like, it's more like gambling at this stage, because you know, we're just looking for people with interesting ideas and an ability to execute, and really like going through a program like HAXLR8R is just to get you to the point where you can prove if your idea is good or not. So most people come to HAXLR8R with like an idea and then maybe an early prototype, and as they go through the program they iterate on that prototype, and our goal is we want them to achieve 2 things. Like at a minimum you should have 2 things done when you leave. One is have your final prototype that is manufacturable, and 2, have your manufacturing partner kind of lined up so that you know, okay, we're going to go launch this in the US, and we know that if it's successful, we can manufacture it, and we know who's going to do that for us. And you know, you see a lot of Kickstarter projects where they have this great idea, this great design, and then they start going, and then they're like, and it turns out it's not manufacturable, and then they spend 6 months redesigning it, and you know, and that's why a lot of people get grumpy at Kickstarter projects, because they promise the world, but they've never actually been to the factory to like make sure, like they've never put it in front of the people who are going to make it and say, what do you think of this? And whereas in Shenzhen you can have this interactive and iterative design process where you say, you know, hey, we got these prototypes, like we want you to make them, what do you think of this? And then, you know, good factory will say, okay, well, we like your idea, but maybe if you could make some changes here, it'll be easier to injection mold, or it'll be easier to assemble, and that sort of stuff, and give you feedback on your design.
about all the staff that apply for funding from Accelerator. Where are they from?
Yeah, so we have a pretty diverse makeup. We have 10 companies in this program right now. 5 of them are from the US. We have 2 from China. We have 1 from Singapore, 1 from the UK, and then we have 1 from Canada. So, definitely. I mean, and that actually reflects pretty well the kind of distribution of our applicants. Like, we got like 80 some applications, and like half of them were from the U.S., and then the other half are kind of distributed across the world.
Yeah, I remember you told me there was only 1 team from local mainland China, right?
That was last year.
Okay, that was last year.
Last year we had, I can't remember the exact makeup of last year. But yeah, last year we had one company, which is MakerBot. They make kind of like maybe Mechano or Tinker toys for adults, like robotic building blocks that are made of like real aluminum, and you can like make real things out of them. And they're doing really well. They had after the program, they launched on Kickstarter, and they pulled in like 100K something US. And then they spend a year, they ship that, and then they spend a year kind of like iterating on their design some more, and then they launched again on Kickstarter like a version 2 and pulled in something like 250K. And meanwhile, they've continued to do sales and brought in revenue, and they're doing really well.
Do you see a trend that there are going to be more local Chinese entrepreneurs applying for accelerators?
I think so. Yeah.
Okay.
We've this is our second year doing this, so I think word is kind of getting out a little bit that there's something like this going on in Shenzhen. Last year we kind of just came in and did it and didn't really advertise or anything. But this year we've done a few like press interviews and stuff with like Chinese media instead of just like the normal TechCrunch US tech media. So I hope so.
So compare with the Chinese teams. If you compare the Chinese team with the Silicon Valley's team, what are the Chinese team's weaknesses and strengths? Yeah,
so I mean, it's not really good to generalize, but I'll do it for you, man.
Okay.
So I mean, just one of the things I've noticed is that the Chinese teams are really not as good at like marketing and kind of understanding like their customers and like all the sort of business. Like the marketing side of business. They have trouble like, all right, should we sell this to someone else and then they deal with selling it, or do we do our own brand, or whereas like the US companies mostly understand that. I mean, some of them still have like, how do we market this to people, or we're just going to sell it to nerds and that'll be good enough. Whereas like then on the flip side, like the Chinese teams really understand like the supply chain and like this Shenzhen and Southeast Asia is their home turf. Like they just have not a lot of problem like going in and communicating. Obviously, there's no language barrier, and that's definitely an advantage.
So what general advice you would give to the Chinese who would like to build hardware as their startups?
Man, I don't know. Probably a bad mentor for that. I mean, I think the biggest thing that I see is people like hesitating and second guessing themselves. I mean, it's good in like we were discussing agile startups. I mean, it's good to not be like married to your idea and not be like to take a critical look at it. But I think some people take that a little bit too far and like, oh, is this right? Are we not doing it right? And like it's okay if you're a founder to have a vision and be like, no, we want to build this awesome, cool thing, and like keep that as your vision. But as you work towards that goal, like analyze it as like, okay, is this going to achieve it? Are we going about this in the right way? And take a look at the big goal every now and then, but it's okay to stick to your guns and that's part of what being an entrepreneur and like a founder is having this idea like nobody's done this before and going after it.
Mm-hmm. Okay. So I think these are pretty much what I would like to ask tonight, and I think it's time for taking questions from the audience.
I think he was fastest over there.
Yeah.
Say you had a prototype, like somebody on Kickstarter, but you didn't know how to go about manufacturing. What would be your advice to somebody that wanted to make something in China?
So in this situation, have you gotten money from Kickstarter? And
Just a theoretical.
not you, but like the theoretical person.
Let's say they've done a prototype and maybe they designed it in the U.S., but then they need to manufacture it. They haven't really
If you have money, I would highly recommend like hiring someone to kind of help you through the process, because it is tricky, especially if you don't have the skills and you don't know even how to decide like if a factory is reliable or not. You know, having someone who's been around the block before help you out. And there's a lot of companies that have done that. And, you know, you can probably find people on Kickstarter and ask them like, hey, how did you go from like idea to success? You know, if you don't have money to make that happen, I mean, you could try find people online and see that. It seems kind of risky to me. You know, another way is like, depends on how dedicated you are. You just like pick up and move to China for a few months or whatever, or a year or forever. You know, that's the best way, because then you can just go camp out in the factory until it gets done. I mean, at some point in time, you're gonna have to put it in front of people and have them tell you if it's good or not with their money, but or apply to HAXLR8R and we'll help you.
Okay, next question.
Actually, I don't know how good the technology is. Actually, I heard some news saying that they use it to make a gun only shot like a 6-bullet or something.
Oh yeah, don't shoot.
But what I'm
gold
trying to say,
plastic.
what I'm trying to say, right, is not that. I'm just saying that going forward, I think there's a lot of potential, and I believe one day, I don't know how long, but I guarantee you it will be there, at least for the kids, right? So I'm wondering, is there any thinking about it, right? You know, thinking about, say, you know, if I can authorize myself, I say I'm going to pay this much of money, and here is my drawing or whatever, right? I can ship it to one machine out of the lot somewhere, instead of a toy store, it could be this machine store, right? And then he will produce me a toy, say, for my kids or grandkids, whatever. And then after 30 minutes, I go to pick them up, right? Everybody happy, right?
Yeah,
is it good vision or bad vision, or actually it's just...
No, there are people that have been trying to do that. I mean, there's services online like Shapeways where you can upload it and then they'll mail it to you. There's, I want to say maybe 100K Garages was trying something similar with like crowd-based like digital fabrication, where there's like this network of people that all have machines and like you upload it and then it gets distributed out. And there was even like I think Kinko's and Imcore or something in Europe. There was a partnership where like at a Kinko's kind of like copy shop, they also had these kind of 3D printers there as well. So you know, that kind of thing is coming, but.
Cool. Thank you.
Mm-hmm. How far do you think we are from 3D printing house or food or?
I mean, people have done that sort of stuff before. Printing houses, I think, is going to. I'm not really an architect, but I know that if you had a way to digitally fabricate buildings, that architects would go crazy and just love that, because you know they don't have to be limited to like square, like rectangular things, because they're easy and cheap to produce. There's a few companies that are building like large scale, large format printers that work with like concrete or plaster. I personally want to live in a 3D printed house at some point in time, just because that'd be sweet. For printing food, there's been a few different people working on that. Like, I don't know, people have done stuff with chocolate. At MakerBot, we made one that printed frosting, and frosting and jam. And we were at a hackathon one time, and we made this project called the New York Toast. And we took pieces of toast and jam and peanut butter, and then we printed the daily weather onto your toast. And the idea is like every morning you would go downstairs and like there would be your toast on the thing, and you'd be like, oh, it's going to be hot today. And you eat your bread, and then, like no paper was wasted. Like you ate it. It was kind of this nice cycle. But I think the problem with food is like food is such a there's so many different things that go into it, and most 3D printers are designed in kind of like one material, and then you just put that one material in whatever 3D shape. So, and also people tend to be very passionate about food, and oh, but it's like this thing that's so ephemeral, and like robots could never do that, and I'm sure they could, but I think it would be difficult for people to accept that.
So I have another question. Please.
Go ahead. Yeah,
Oh.
Alex. Yeah.
Yeah, I mean, I would like to see something crazy. I don't know, like a 3D printer, like you said, embedded in a robot and moving around and really building stuff. I mean, like not only just a 3D printer, but also doing CNC and things.
If you want to see
like,
something crazy,
you know,
Google,
like, really-
Google hexapod CNC face. And there's this video on like the internet somewhere of like a hexapod, you know, like the little spider robots with 3 legs. And in the middle, there's a CNC like spindle, and it's milling out like from a chunk of wood a human face, but it's like a spider robot with like a spindle in the middle. It's really freaky, but it's also really cool because this thing's just walking along, and then it like CNCs something, and it's. I think that's exactly what you're looking for there. Is
I mean, I was thinking of something that could really create abundance of value by, like it kind of self-replicating, you know.
Yeah.
I told you before, like I studied nanotechnology, and during a lot of time people believe like nanotechnology was going to be the next revolution because it can self-replicate, but yeah, I think we should first start with macroscopic things, and then, I mean, that's why I'm looking for really examples like where you can really replicate the full machine, can replicate and assemble itself or something. That would be.
Question from the lady?
Okay, yeah, so besides fun and crazy ideas, so what do you think are the actually promising and practical field most for 3D printing?
So I think on a more practical side of things, I think that like small batch manufacturing is kind of where 3D print, like the consumer grade 3D printers as an industry are going to go. That and mass customization. So, you know, one of the things I've seen so many times with like the companies coming over to Shenzhen and just like hardware startups in general is they have this good idea, and you know, they want to make it into a reality, but they also don't want to take investment because maybe it's like investing. Not only does it take a lot of time and money, but you really got to be able to convince someone that's a good idea. Whereas, you know, maybe your idea is not like a massive market. Maybe your idea has like a few hundred people or like 1,000 people that would really want it, but you know, there's not much beyond that. And so if you had a way that you could economically produce like 100 or 200 of something and have it be good quality and get it into the hands of people, you know, I think it would really help small companies be able to bootstrap easier because, you know, right now it's really hard. There's like this very difficult place between like 1 to 10 of something and like 1,000 and up of something. Like if you have 1,000 and up of something and you have a market and customers that can do that for you, you know, it's tricky, but it's not that hard. But if you just want to sell 200 of them, like you can't do it by hand. If you do injection molding or something like that, it's just way too expensive. And I think there's a really there's a niche there for a machine. Or I personally think that as 3D printers come down in price and kind of get to an acceptable level of quality in their output, you know, I think it's probably going to be somewhere between $750 and $1,000 US, and like, you know, I don't want to get too technical, but you know, like a good output quality, you're going to see people using these commodity machines to build small-scale businesses. The other thing that I think that would do is allow these companies to iterate really quickly. So, you know, maybe you have a market for like 10,000 a year of something. Maybe that's a little bit too big. Maybe like 1,000 a year of something, and you could, you know, so that means you're making a few hundred a month. And so, if you're doing it digitally, if you're using a digital fabrication technique, you know, as you're going through this, and keep in mind these are startups, so they're going to be iterating, they're going to be learning lessons as their customers report back, they're going to be finding problems. If you have a digital process, you can fix those on the fly and say, okay, oh, we found this, all right, fix that, change this size, move this thing around, and you're going to be much more adaptive and responsive to your customers, which is how the really good companies are made. Whereas if, you know, say like, all right, we can sell 1,000 a year, let's get a tool made, let's do this, and it's like, and we have 1,000 pieces that are all broken now. And, you know, and then you have to like do triage and like put bandages on it and come up with hacks to fix that. So I see a few grimaces out here of people that have probably dealt with that.
Ulrich?
Yeah, I actually have a couple of questions. So I'll start with the first one. There was a question earlier about whether you can order 3D printed things online and so on. And so I was wondering, if you think about how normal 2D printing, all the different ways you can print something. You know, if you want a business card, you can have 1,000 made at a professional shop, or you can order them online, or you can order them. You can go to a shop nearby in person, or you can print them at home. Do you think how do all the different ways in which you could get 3D printed stuff? How are they going to evolve? Do you think it's going to be a similar, like, wide range of options for all kinds of things, or is there like some structural differences?
Yeah, I mean, I think it's going to be a little bit different. I mean, I think there's definitely going to be the wide range of things. I do think that kind of the final like settling price of 3D printers is going to be higher than the price for a 2D printer, just because they're a little bit more complex, like mechanically, and just physically they're larger machines. So just from a raw materials perspective, they're more expensive. So, you know, I don't think that it's going to be difficult to get one in every house. Like almost everybody has some sort of printer or access to one, like right there. But you know, I think with 3D printers, like you need to have a need for it a little bit more. So maybe a little bit more centralization in like, you know, print shops or online or whatever. Especially for the higher quality ones. I mean, I think unless you really need it, like you just go outside to a shop for the high quality stuff. But you know, if it gets low enough, and also if the machines become useful enough, and I think there's a combination of both software and also just availability of stuff online. Like you know, one of the reasons we started Thingiverse was, you know, back when I was just building rep machines that barely worked, the question was like, oh, well, what am I going to print with this? And I'm like, but dude, it's like a file, and people can email you, and you just download it from the internet. And they're like, oh, I can download from the internet? Where do I download stuff? And it's like, oh shit, we should build that. And but you know, like now there's tens of thousands. I'm not even sure what they're up to now, but there's like tons and tons of stuff online. You can just cruise through and say, I like that, or maybe I want that in my house. And as that gets bigger, you know, and if the parts continue to get better, I think it probably becomes pretty compelling to like, oh, I could have a 3D printer in my house, so I could, you know, make stuff.
So right now, cheap inkjet printers, the main cost is actually keeping them running, which is something we have failed at. We still don't have a printer. We have 15 employees, and we can't seem to get a printer working. Is that situation for 3D printers? Do you think, like, generally the cost of keeping them running versus the cost of buying them, which one is higher? Is it a similar situation as with
yeah, I mean, right now, 3D printers are just, I mean, it's you gotta give it some TLC to keep it running and printing.
Okay,
But
we won't try them.
you know, I think there will be a time in the future where they're more reliable, or at least the good ones are more reliable. You know, like the name brand 3D printers, so you can just kind of count on them opening it, hitting go, and then making you something.
Okay, but the cheaper ones, basically, you want to know how to use them and keep them
exactly.
working, which
Exactly.
we also have an expert at.
Okay, question?
I have like two questions. One is in addition to what he was saying. So you say, you know, hopefully in the future they will improve. Is it going to become a model like HP, you know, sell the printer cheap and then charge like an arm and a leg for the material?
Yeah, I'm sure there's going to be a company doing that. It would not surprise me.
Yeah,
at all.
so which kind of drives into my second point, which was, you know, you had talked how you have open source, and so you have open source versus closed source, and you know, I won't drag up the past, but with MakerBot, so
yeah, it's probably going to be MakerBot, which really sucks.
so in other words, given what you know, your experience, if you have this clash within any organization of open versus closed, how do you have any tips on resolving that, or is it from the get-go?
Oh yeah, totally. Don't take investment money. Step one, if you have an open source project and you know you want to and that's an important part of what you believe, because I mean investors, unless you find the right one, which I'm not even sure they exist, like they just don't understand open source. Like they typically don't understand something that you can't assign a monetary value to, but generates like goodwill and customer loyalty and that kind of stuff. Like you can't say, oh, but our being open source makes people love us and so they'll continue to buy our products. They're like, yeah, but can't someone copy it? And you're like, nah, yeah, of course they can copy it. That's why it's open source. And that just leads into, oh man, it's
So
I've seen there's a lot of successful open source companies that did not get to where they were because of venture capital. They got there because they built a good product, they sold it for more than it cost them to make, they treated their customers well, which is part of open source. Like you treat your customers how you want to be treated, as inclusive and hey, here we built this for you because we are you, and here's this thing. And you know, they just built a solid real business that has a reasonable markup, like took that money, put it into growing the business, and over the course of 4, 5, 6 years built it into large companies. Like you have SparkFun, you have Adafruit, you have 3D robotics, you have Seed Studios here, or not here in Guangzhou, but here in Shenzhen. You know, and there's dozens of smaller companies. I mean, MakerBot was that way. Before we took venture capital, like we were doing something like 6 or 7 million in sales a year, and just because like I started shipping plastic to people from my like apartment in Brooklyn, and it just kind of snowballed and grew. I mean, that's the wonderful thing about a hardware company, is that you can go very quickly to getting that revenue. I think I've had this conversation with multiple people, but if you're selling something physical and once you get to that point where you have a saleable item, you can start small, you can have your kind of core group of customers, you can sell it to them, get their feedback. Like the best kind of feedback you're ever going to get is from someone who's put down money to own something that you've made. Like if you go to like friends or people that have never put money into it, you know, they'll be like, oh, it's great, and oh, it looks wonderful, and it's like, you know, no, your friend is never gonna be like, oh, this fucking sucks. Like I can't. Like they just don't. Like your friends don't do that. Whereas like if you sell someone something and it doesn't work how they want it to, they're gonna tell you in like the clearest terms possible that like exactly how it doesn't live up to their expectations. And but yeah, getting back to the original point is in hardware you can sell small amounts, get feedback, and then iterate and do it more. Whereas like with a web startup, like, okay, you get 100 people using your website, great, like you just earned 2 cents in like ad money, you know? Like you have to get that scale and that volume before you can even try and bring in decent amount of revenue. So hardware, I think hardware is a lot easier to scale. It's a more difficult business because there's like a much wider range of things that you have to be good at. But it's also the kind of thing where it's much easier to start small and grow gradually.
Okay, David.
One question is that actually when you look at the China market, for example, iPad, you see a lot of different iPads, so-called iPad. Actually, they build upon a certain standard platform. Okay, that one is kind of like open source, so that you can construct different type of Sanjai area things. Okay. But the key point is actually no one is making a good product actually until that one is really a branded one. They have the resources to make it beautiful, make it more mass production producible, and that product will really fit to most of the people actually. So from open source point of view, yes, it's like a geek culture. It's good to make fancy things, but how to make it suitable for the major portion of those people don't understand really technology. But that one, can that be a dilemma over there?
Yeah, I mean, that's where having the company and the resources behind it. I mean, I think the key there is not whether or not it was open or not. It was whether or not there were resources to do the polish and the detail. You know, I mean, when building a hardware project, like the first 20% is just getting it to like, hey, look, here's this thing that works. And then like the rest of it, the majority of it, it's getting every little detail just right so that it has that finished product feel to it. And for that, I think you need a company, like you really need a company behind it. But I think open source can still be a part in that.
Okay. Vincent?
Another question. Not really a question, but I just want to hear your opinion of a Mackie box, was it?
Yeah. I've never seen one or played with one. I've seen the stuff on the internet, and I met John once in Shenzhen. The only thing that I really saw is he has, and like the only thing I've seen physically in person was he showed me one of his extruder designs, and he was doing some really cool things that would definitely cut the bill of materials down. He was doing like flexible circuit heaters where most people are using like heater cartridges, and so like that could be done for pennies instead of like a few bucks. So I don't know, seems like he has a lot of ideas, and
he's selling a small one for 200 US, I think.
I don't think they've shipped any though. I mean
they're on CNN and everything, so.
Yeah. Until you ship something, it's all just a plan.
They say good engineers ship.
Carol or Alex, do you still have questions?
Yeah, actually, I had a question about, you know, like a 2D printer is like a household product. How long do you expect it will take to see the 3D printer as, you know, that household product? And what should happen in the meantime?
I really hate making predictions for 5 years.
Yeah, that fast? And what do you predict in terms of usability? Will a 5-year-old be able to operate it?
I think so. I mean, I think basically what needs to happen is you need to be able to open the machine, take it out of the box, plug it into a computer or your internet or whatever, and then press a button and have it go. And I think 5-year-olds should be able to handle that.
And then even do iterations on designs, or is it just picking from a catalog?
I mean, I think in your example of like a 5-year-old, I think it's going to be like clicking things on a website or whatever and be like, make me that. But there's already like people building kind of customizable, downloadable things. Like there was, I want to say, a website called like My Robot Army, where it's just a website where you go on there and there's like sliders, right? I don't even know what their UI was, but it was real basic, and like you could kind of make a few choices and then it generates you like a robot that you can order from like Shapeways or something. And you know, it's just kind of like a little toy generator. But there's that. There's also like MakerBot released like they call it Customizer for Thingiverse, where you know someone will upload a design and then you can kind of enter your changes or whatever and generate like a custom iPhone case, or like you type in your name and then like your name appears on an object and you have this like personalized thing. And you know that kind of software is still very crude, but I think it's the kind of thing that needs to develop like in tandem with 3D printing, because you know, if you're like, hey, look at this thing, you can totally customize 3D models, but there's nothing to make it on, it doesn't make much sense. And so all the people that are waiting to build that, even if they don't know they're waiting to build that, you know, there just needs to be more like market penetration of the technology, and then you'll have more people playing around with it, hacking it, and
Thanks.
Okay, David. Question is that actually the Japanese is really making good machines, right? So like the 2D print, actually even the HP is made by Canon actually. But why those Japanese guys are so lagging behind in this kind of 3D printer area? What do you think? Actually, have you approached some of the people from Japan? What they're thinking?
maybe they watch too much anime, which is a 2D format.
They're too busy building humanoid robots.
I have one more. Since now we have printers, now what about scanners? I mean, I remember recently.
Yeah, there's there are a lot of scanners out there. I think the big problem with scanners is just the software. To like, you know, there's a dozen different ways you can take like the Kinect, or there's like 123D Catch by Autodesk, or there's like laser scanners. There's like Leap Motion is another one. And, you know, there's all of these things that will generate what we call a point cloud, which is like, okay, we scan this thing and like determine like from here, like here's all the dimensions of these individual little points, but having the computer decide like what is connected to what, and in order, to build a surface, because like in 3D modeling you need like what is called like a watertight mesh that has a very clear inside and outside that is a solid object, and it's just really difficult to do that on like in programming in computer software, and there's software that does that. Like there's an open source one called MeshLab, but it's just a monstrosity of a user interface. Oh man, you know, it's getting there. Mama lie.
Yeah.
Yeah, actually, I just want to elaborate on that a little bit, and I guess for music, right, we have MP3 or something standard. So based on what you're saying, is that it's really hard to have such standard?
No, there's a standard format. It's called STL, and it's awful, but it is standard. And
so that means all the 3D printers are based on those models?
Yeah, I mean, almost every 3D printer will take an STL as the format.
And then
even the professional ones.
Do they have their own, since that one may not be good or something? That means their standard usually people treat a little bit to make it their own, so they can do
I mean, I'm sure some of them do, but STL was, I believe, created by, STL stands for stereolithography file or something like that. I don't know. It stands for something.
It's triangle or something. It's based on small triangle. So if you have a surface which is spherical, it's not that great.
Yeah, I mean, there are a lot of file formats that are better for 3D modeling, but basically the way it is like people will do design in whatever software they have, and then at the very end, when they're ready to do 3D printing, they'll export their file into like an STL. So it's kind of like you're doing your design in Photoshop or Illustrator, and you have a vector format, which is like very nice and can scale and move and stretch. And then when you want to put it on the web, you export to like a JPEG or a GIF or a PNG, which is like loses all that information, but it's a lot more, you know, it's readable by every browser.
Okay, thanks.
One more question from the channel?
No.
Okay.
That's true.
So if there are no more questions, and then we will conclude this session of Staff 5. And thank you very much, Sam.
Sure. for the next session. The applications open like June 1st of this summer. And the next, like the round, it's like 3.5 months, starts in August of this year. So we're doing another one in the fall.
And I can tell you guys, it's a really awesome space, super productive, happy people, and sort of in an environment where they can be really productive, and it's really awesome. So I think it's a really good idea.
Thanks. So as always, you guys, we're gonna have the beers coming. You guys can stick around and get to know each other. And Zach, hopefully,
yeah,
stick
I'll
around for a
stick
little
around.
while.
Yeah.
Awesome. Yeah. So thank
If
everyone.
there's beers, I'll
There's Maker beer, actually.
So is there something like don't drink and operate a MakerBot?
We better put one here.
Yeah.
Alex,
Oh, sorry.